Hi guys, so in this last series of the Introduction to Rhino, we're going to cover what we worked on today and panelizing a surface. So I sent out a panbox morph Rhino file and then a Grasshopper file as well. I would like you to open both for this last portion. So we're going to look at 1A to begin with, and I'll describe what's going on. So the way that you link your geometries between the two is to right-click, select one surface, and click your surface in Rhino. And a lot of you didn't notice this, but because you have all of the grayed out options not disabled in preview, you can't see the final results. So if you just middle mouse click or right click and hit preview, you can see the final output. Within your definition also, you'll see like this is where you start to feed in the information into our container. This is the action that's going on, and then this is the end action. You typically want to see the very last action that you were working with unless there was something at midway that you wanted to preview. So you can turn everything else off because this will become redundant. You can see here that there's like three surfaces on top of each other. I have my actual physical surface. If I click it, I can hit hide. And then if I click this, I can see that green surface that's referencing that surface from Rhino. I want to hide that as well. And then now I just have my ISO trim surface at the very end. So to walk through this definition, what we're going to do is I'll explain what's happening. Disregard this and this. So we have the surface set, and it's just, this was a simple doubly curved surface that we made by changing the control points. Now within each of these surfaces we covered in class, if I make a copy of it, and then also hide all of these for now, there's information that's relative to each surface called the U and V curves. If I type in rebuild, this is how we explained last week how you start to manipulate these. So if we type in preview, you can start to see the lines or the NURBs that are going across this surface. These are called the ISO curves. So they hold information on the curvature and the UVW mapping intrinsic to this surface. So you can see that the U count we have set at 50, the V count we have set at 15. So I'm going to guess that this is the way the U is because there's 50, and then there's 15 running in this direction. You can see the direction of our surface here, and that we have this slated to be a 1 degree curvature. I'm going to change it up to 3 so that we don't lose the curvature of it, and hit OK. So now if I were to hit the control points of this, you can start to see that information. If this is unclear to you, go to Digital Toolbox and select some of the Rhino basics, and it'll explain the U and V direction ISO curves of a surface. So now that we have our surface linked, I want to deconstruct this surface based off of its domain. So within each surface there's a domain that is set within it of these U and V's already, which we just controlled in a way. If we were to click and see this, if we do this here, you'll be able to see the domain that we're suggesting that it is changed to is a series of UV curves, and then it says their starting and end points. So when we ask for a domain, we're getting the starting and end points of the U and V curves across that surface. This is called divide domain 2. It means that there's a domain in the X and the Y, or a two-dimensional series of elements. And what we wanted to do was deconstruct this and remove the information so that we can start to say a rebuild in pretty much Grasshopper. So the divide domain 2 is a method of doing that. We can increase the counts here of both of these elements. So this is called a slider. If you type in number slider, you can begin to play with the counts based off of this degree. To change this to a higher number, you need to double click here, and you can set it to be all real or floating point numbers, integers, even or odds. And then you can double click here to set it to be whatever maximum you want or whatever minimum you want. I'm going to delete this for now and use this back to 7. This one is set to be all integers, full number integers, and not floating point. Sometimes you want the floating point because you want the specific decimals, but generally I think I've used the integer one or the full number, or what is this? Yeah, integers more often than not. So you can plug these into your U and V, and this will control the count for that. If we hook this back up, you'll be able to see this change over time. I'm going to disable my surface, and so right now all I have is this last component on which we haven't covered yet. But just so that you can see the way that this is changing across the surface and it's rebuilding those isocurves quite clearly. So now that I have a deconstructed surface with a rebuilt isocurve, I need to somehow put this information back into a component that can produce a surface for me. If I were to preview this, it can't because it's an action for deconstructing the domain. It provides a series of segments, and that I need to use these in some fashion to create a surface again, because then I just have a surface that's being deconstructed. So for this component, we're going to look to the isotrim or subsurface. You can call your components out by double-clicking and hitting isotrim here, or you can also go up into surface, I believe. I hope this is right. I never use this method. Yeah, isotrim under utilities and surface. So with this, what is it asking for? We hover over this, it's asking for a surface, our base surface. Okay, that was the initial thing that we had. We link these two up. And then it's asking for domain, a domain of subset. So if we deselect this, you can see it's saying just a domain, or we right click this and hit help, a collection of two-dimensional domains. So as we just used this two-dimensional divide domain, this information is perfect for what the isotrim needs. If we hook them up together, obviously it's worked before, and I just wanted to show you, since this is a double line, the type of information that's coming out of here, which you should know is one list with multiple elements within it. If we scroll all the way down to the bottom, you don't see that there's any more lists indicated, and there's only 0, 0, so one list within that panel. So what this isotrim does is that it segments or cuts every U and V down into the panels that are created. So if I were to bake this, which you can middle mouse button push down, hit bake, you will start to see that these surfaces are developed in between those isocurves that I had indicated. So I pretty much split every curve with every curve, and then I get the panel that is in between them. And for the first definition, this is what we're going to just pause at for now, is panels from isos. The homework for this one was to rebuild your component into a series of surfaces and apply this paneling to your component such that it created some unique conditions where you have moments of force. But this is all clarified in the email. So for now, this is where we're going to stop. We'll pick up with diagrids and how to call out specific information within this surface, and the point control within each one of these quads.